Yo, what's up, guys? Hope you're doing well. Welcome back to another video. It's been a long time indeed. First video of 2025. I wasn't really sure what type of video or topic should I cover, and that's why I've decided to make a tutorial or informative video on how to design a solar PV system using Helioscope. I'm not going to go into the pros and cons, the overview of what it is, what should you expect, the features and the outcomes. If you want me to make another separate video on that and compare different softwares out there like PVSys, Open Solar, whatnot, do drop a like, comment down below in the description, and yeah, so I'm just gonna get to the point and teach you guys a simple, basic solar PV system designing using Helioscope. Now, Helioscope, it's an online website tool that you can create your account. There is a free version, a 2 weeks, 14 days version that you can use an email, another account, and then just sign up, and then you get 14 days to basically experience the Helioscope user interface and get start designing. So once you log in, you get to the home site, the home page here. Now this is the old background or user interface UI for the Helioscope. There's a new experience, which is here, the new Helioscope that you can try out. But as soon as you log in, you can see your projects, which I'm currently working on with my client. And so in the projects here, that I want to basically go into the new experience, which is great. I recommend you guys to check it out. Try the new Helioscope version. It's really great. The experience of designing it, getting to see the reports, the simulation, whatnot. So here it is. This is the new version for Helioscope. You have the help, feedback. You can search for your projects, share with people, archive, um, and this is the new project button. So when you click on that, you basically enter the name of this project. So I'm going to call this a demo project. Okay. And then the address. So, I mean, I'm just going to take a random address. I don't know. Like, let's take any place in the US, Arizona. Um, let's see. Let me just enter a random zip code. I don't know any address or place in Arizona. Let me just go with this 1 second. Let's see. Okay, let me just get a random address in Arizona, USA. Uh, okay, there's 126546 Scottsdale. Okay, so let me just copy this address right here. All right, and let me paste it. Let's see what type of geographic location do I get. Okay, so it's a road. Let me let me take this building. This is a rooftop commercial level. We can also take some houses. You know, uh, like here, and get some solar on them. So what else? Yeah, okay, we'll just take this one. All right, so I'm gonna say uh, residential project. All right. Okay, so yeah, create project, and once it's loading, you guys basically gonna see this, right? So this is a overview of what you should expect from the project. So details here, the address, who's the owner, location. So this is the longitude and latitude, and the utility rate. So whatever rates that your electricity provider is setting out for you, the flat per kilowatt hour rate, you can change it. Apply net metering. Need that to import the energy from the grid. So this is the credits that we're gonna get. Annual true up period. Reconcile net metering credits every 12 months. So this is basically like kind of every 12 months resets the credits, so sets it to whatever value you want it to set. So at every if we export it to zero point 0.5 or 0.05, for example, dollars per kilowatt hours, so after 12 months when it reaches to that rate, it's gonna basically cut it off and then start again from zero. So whatever amount or net rate that you want to export it, and every 12 months you want to cut it off, you can adjust it here. So, or you have a manual consumption, so how much of your electricity bill having per month, or you can have it a file that you can upload it here. Incentives from the government, so tax credit 10%, 26% from the U.S. federal credit. So you can also add that in, how much you're going to get paid by the government. There's a percentage of that incentive. Financial inputs, any metrics later on once we simulate the solar design is going to show up here. Project Files Explorer. So this is the designs, the AutoCAD layout, the single line diagrams. So it's all going to show here, along with the reports. Simple proposal, residential proposal, production report, shade. All that report's going to show up once we simulate and design, and the financial as well, the payback period, the ROI, the internal rate of return, the lifetime value. All these financial projections, levelized costs of energy, LCOE, whatnot. So this is very important. On the left hand side, you can see a menu where it shows the overview, design, financial. This is in the pro plan feature. You're going to see that more in detail. Simulation, the conditions of the weather, sharing, reports here, library. So I'm going to go on to the system design. So it's telling me to complete your design. So I click on edit, and here you are um, in the geographical location. So immediately you're going to basically come up and see your location. You can play around, see where what you're dealing with, the type of location it is, the rooftop. How is it? Is there any obstructions? Is there any shades like trees obstructing the rooftop? Something like that. You can just see and play around with. Right click, and if you wanna zoom in, just use the mouse wheel to zoom in and out, and then just left click to kind of go around and see where you wanna, how your solar system looks. On the left hand side is the design one. You can rename it to whatever you want to call it. You have the mechanical, which is the solar array that's going to be installed on the rooftop. The keep out, so if you want to basically add any obstructions. So for example, we have obstructions here, right? So you just want to click on this, and then you can basically zoom in, so using the scroll wheel, and then just basically outline the obstruction, or the keep out object. And then once you're done, just double click, left click, right, and then boom, you're done. So, and if you want to move this around, you can just click on this arrow, which is here, and then kind of move it around and you know adjust it. If you want to make another copy of it, you can just click on this, Control C, Control V, and you have another copy of it, right? So you can just do that, and basically, yeah, just fidget with it, play around with it. And I'm gonna do that for all of the obstructions. Keep out. All right. So make sure that now you're not gonna get the most accurate placement, because obviously you can see this fuzzy little pictures and obstructions, and you're gonna miss out on some things, right? So um, you're just gonna get an ideal estimate of how the obstructions are gonna look like and how you're gonna block them from the panels that are gonna be installed and in place. So as you can see on the left hand side, these are all the keep outs that I've made. You can adjust them, you can delete them, whatnot. For a tree, you can basically see that if I have a tree right here, I can click on it, and then from here I can adjust the diameter length, and basically it's going to show me the tree and its shadow projections throughout the day. How's it looking? So, I mean, obviously right now it's showing us that the shadow is flashing on that side, but it's not really causing an issue to our rooftop solar. So we're just gonna delete it. You don't need it, but you can definitely add it. So you can add the tree obstruction as well, the feature. The electrical option here is for the inverter and the wiring, DC to AC ratio. Later we're gonna do that. The advanced is for the shading, overlays, LiDAR. This is in the pro plan feature. We're not gonna touch that, but we have the overlay. Any objects that you have or pictures, you can upload it. The shading for the rooftop, once you add the solar panels, you're gonna do the shading analysis later. So, all right. So first off, before we uh, do this, we're gonna make sure that we need to choose a solar module. So any type of module that you kind of prefer or want to, you can do that. But so just click on new. So click on the plus sign, create new field segment. Click on the map to create a field segment. A field segment is a valid area to place modules. So giving you a tip here, while drawing a field segment, hold down the shift key to have a new lines automatically snap to angles in 30 degrees increments. So if I, let's say, click on, if I start on this one, for example, okay, wait, let me first make an obstruction to keep out for this area. There's an air conditioner, if I'm not mistaken, the aircon. And there's one little tip, guys. If I press and hold shift, right, watch what happens. You can see it creates a like a fixed angle for every 30 degrees, right? So it makes it a smooth straight line. So it helps you to kind of give you a more accurate drawing outline for that obstruction. And once I'm done, double click, and look at that. It's perfect. And you can do the same thing for these guys, right? This is not really clean and aesthetic and crisp compared to this obstruction, the keypad that I made. I can just copy and paste it and do the same thing for for the roof. I can adjust the height here because it's kind of small. So I can just drag one of the corners and just extend it here and do the same thing. And voila. All right. So just do the same thing uh, for this one, and I'm done. All right. So now let's move on to creating a panel. So click on new. All right, and then do the same thing. So I'm gonna do this. Click here, shift. All right, click another one here, shift, click, move. If you wanna, oh yeah, another thing I forgot to tell you guys. To get this type of orientation layout, you have to hold shift and then just left click and then just kind of move around and see another POV angle uh, just to get a better idea. So yeah, press and hold shift and then just move around with your mouse. But yeah, so I'm gonna click here. I'm still holding shift, by the way, guys. If I remove shift, guess what happens? See? And if I just left click, I can just move around like this. But if I hold shift, and then you can see how the lines are completely fixed, specific, which makes it more accurate for your design. And if I left click it and I move around while holding the left click, I'm getting it right. So, all right. So yeah, right here, I think that's fine. Click, then position again, then click again. I'm just gonna make for this rooftop, just to make it easy. Click again, and then done. So as you can see, it gave me a segment, field segment. It gave me the area, which is 768.6 feet squared, square foot. And then the module now. It's telling me to select the module now. I don't know which module. Should I go with Canadian Solar or should I go with, um I'll go with Canadian Solar. Why not? What not? Let's see. Well, I'll go with a 400 watt, 415 watt module. And here it is. Now, automatically once you place it, it automatically adds the appropriate modules on the roof, and then from there on, you can just adjust the module's height. So on the left side, once you do it, you can choose which type of racking you guys want. So fixed tilt, flush mount, east-west racking, carport, shade structure for the car parking for the cars. East and west is more for agricultural design. Flush mount, I believe it's more of a tilted for ground mounted system. You use flush mount, if I'm not mistaken. Fixed tilt. We're gonna keep the fixed tilt. Actually, no, let me Google flush mount. Flush mount racking system for solar systems, solar modules. Right. So let me learn while I'm doing this, right? And this is a really key thing. So a flush mount racking system for solar modules is a simple, inexpensive way to mount solar panels on a roof. The panels are installed directly onto the roof, flush with the surface. So basically, flush mount system for on Helioscope is preferable for your rooftop, and it automatically sets the tilt angle based on your roof, which is 15 degrees. And if you want to see it, you can again, like I said, zoom out using the the scroll wheel, the mouse wheel. Press and hold Shift. Press and hold the left click of the mouse, and you can see it. So you can see it, and you can zoom in, and boom, it is 15 degrees tilt angle, right? So automatically like that. Now, for a ground mounted solar PV system, so if it's on a ground mounted, the tilt angle here would change and it would be the same angle as the latitude. And in our case, the address that I entered was 35 degrees. So the tilt angle here would change to 35 degrees for a ground mounted system. But since this is a tilted rooftop residential solar system, we're going to go with the flush mount, and for that, the tilt angle is telling us to set it to 15 degrees Celsius. 15 degrees, all right? So here it is. And it's giving you an overview of how the shading is going to be as well. So, all right. So azimuth is 180 degrees. Now, reason why is because it's facing due south. It's in the northern hemisphere. The latitude and longitude is telling us north. And the compass as well as north is that way. So therefore, the ideal should be the panels facing due south. So right here towards me, which it is, and that's 180 degrees. If I do it 0 degrees, it's gonna be facing south, north. See, and if I do 90, facing east. If I do 270, facing west. Right. So we want it facing south, 180. All right. So now let's go into the. This is the orientation of the modules, how you want to look. So right now this is in portrait. If you want in landscape, so this is in landscape. Sorry, this is in this was in landscape. This one now is in portrait. Ideally for a rooftop mounted, uh, I prefer horizontal. In that case, if the reason why horizontal, if there's any obstruction or shaded objects covering the solar modules throughout the day, then go for horizontal, landscape orientation. However, if there's no obstructions or anything bothering the solar modules and it's perfectly fine, and as you can see, there is no objects obstructing it. We covered it except for this one, but we can adjust it later. I think it's better to go with vertical, and then from there on, you can see that our modules are 7.9 kilowatt hours, 19 modules. But anyhow, so let's go with this one. And then the row spacing. Now, row spacing is the distance between the front and the back side of the front to back adjacent rows, the racks that are basically between the solar modules, right? So as you can see, this is kind of not good because if we keep it 1.6 or 1.5, you can see the distance between them is short, and if we do this shading simulation, it's going to be bad, right? So if I click on the advanced then the shading option, and if I do it with this row spacing 1.5 square feet, 1.5 feet, and if I do it analyzing it, it's giving me a shade loss of 0%, 0%, um, which is ideally, in this case we don't have any shade, right? No objects blocking us, so that's why it's telling us 0%. But if I, let's say, increase it to 2.5 meters or 2 feet, sorry, 1 second. All right, so if I make it, let's say, 2 feet, so now I've increased the row spacing, 7.9. If I make it 3, um, yeah, so 8 kilowatt hours, right? So it kind of adjusts it based on your preference. Um, I'm gonna keep it 1.5. Module spacing, keep it the same as it is. Frame spacing, again, keep it as it is. Setback, this is the setback, as you can see, which is the edges of the field segment that we created. That's the edges, right? And for that, we want to keep it 1, 2, 3, or you can keep it 1.5 or 1 meter, 1 feet, based on uh, your the area, the edges. Since we have it here, you can see on the air conditioner, we can see that there's a rooftop setback. We can kind of adjust it to, let's see, 2 meters, no, 2 feet won't work, 1.5 with the setback of 1.5. 2 feet, it's kind of not that great. 1.5 or 1 feet is fine. If I do horizontal, I'm able to get more modules, but I'm generating less. And if I do row spacing of 1, again, it's something that you need to really understand and see based on that the appropriate orientation of your panels and the row spacing as well. Ideally, 1 feet is the best option, 1 to 1.5 feet, um, because you want to basically get more generation if you focus on that. So the setback 1 feet, that's fine. The row spacing, we can change it. So row spacing 1 feet is fine. If we do 1.5, that's even great. And then the orientation for that, I'm getting 5 kilowatt peak, which is less, which is less than 7.9 that we got before earlier. Um, if I do it this layout or arrangement, you can go for whatever feels best. Let's see. I have 5.6 kilowatt with this orientation. Um, and let me align it this way. As you can see there's some hindrance here. Now, if you want to just see the field segment how it is, you can click on this array button, toggle the array visibility, and you kind of see how the solar modules kind of, you know, uh, really breaking or obstructing this edge here. Or if is it not, in 2D it does, but in 3D it does not. So we'll keep it as it is like that. All right. Um, yeah. So let's go on shading analysis. Let's see how it's looking. 14 modules, 5.8 kilowatt of our total system. Um, and there we go. So you can look at the monthly values, looking great, awesome. Uh, yeah. So horizontal landscape orientation is more preferable. How it is. You can also see on rooftop on residential, it's more common as well. But you can have a portrait as well. But we have to keep in mind the shading and the obstruction on the rooftop not being able to affect your solar module and how that will affect your optimization and your voltage level. So yeah. Okay, so now I'm going to move on to the inverter side. You can also do the same thing and design for this top, for this roof. But I'm just gonna keep it simple and go for here. Go to electrical and then select the inverter. I'm gonna go with Solus. Let's go with Solus. Why not? Solus, 3.3, 4.5.3 kilowatt sounds ideally great. 5.3 kilowatt peak nameplate for the inverter. DC to AC ratio 1.10, and you can see it's automatically it does the wiring config arrangement for the solar modules. So we can also uh, can we change it? Okay, so the this inverter you can also add combiner boxes, a DC combiner box. You can also, so if I add a DC combiner box, it kind of shows you how many poles, the copper wire size, thickness, 10 gauge, 8 gauge AWG copper wire size. um, and yeah, it's basically just like a conduit for the wiring that goes from the modules to the inverter. And you can have it set so it does it automatically. And then once you have it done, you can just kind of save and exit your design. So just wrap it up, have your design, save and exit. It will show here the layout, a preview of your design on the right hand side. It takes some time to load as well, but it'll show here. And then once on the then you have to simulate it. So you go to the simulation and click on simulate. So it'll give you a generation of the annual energy yield, which is 1,744 kilowatt hours per year. Performance ratio of 74.7%. grid power of 10.1 megawatt hours. So now if you look at the report, the production report, we can see the generation, so the losses. You can see, so if I zoom in, just for you guys, so yeah, this will be much ideal. So you can see your project details, system metrics. So our module DC solar system 5.8 kilowatt, inverter 5.3 kilowatt, load ratio, annual production of 10.1 megawatt hours, performance ratio of 74.7%, kilowatt hours per kilowatt peak, the specific yield, which is at 1744.1, weather data set, simulator version, the production, so you can see it per month, how much you're getting per month in kilowatt hours. And then on the right hand side, it's the system losses. So shading is zero, reflection 3%, soiling, irradiance, temperature is a lot. Temperature as it get hot, it's going to affect the solar modules. Heats up, and that affects the voltage levels kind of drops and affects as well. The inverter is 4.4%, wiring 0.4, mismatch 1.9. So all these things you can look into it in detail. You have a table as well, monthly shading as well, system BOQ, monthly shading, and then here's the design. So if I zoom out, 1 second. Yep, this is the design configuration. Here it is in more detail. Design wiring. How is it? Is it configured as well? The combiner poles, along racking, array, field segment, the technical stuff, details about how the modules are, orientation, flush mount, or whatnot. And then the residential proposal for the residents, homeowners. They can see this. You can basically adjust it and send it to them, the PDF, and they give them a more better idea on how they can, go with solar. Right? Makes sense to them. You can see it here, a more 3D simulation. Um, the shade report. The shade report is, where is it? Yeah, this is the shade report. So it shows the heat map. Is going to show you um, how the shade is going to look like. It'll take some time to load. The solar axis by month, so per month. So this is the heat map. So this is the heat map. This is going to show you basically the green is basically the sun axis that the solar module is getting, which is great. So green is good. If it's red or yellow or orange, it's not good. So it's not going to give you the best ideal sun axis and the solar radiance. So yeah, that's the shading heat map. Simple proposal. If you want to have a simple breakdown of your proposal, here it is. So you can see your solar proposal prepared by this person, prepared by this, prepared for, prepared by, your energy costs. You can adjust it, see it, utility expense, energy consumption, how much CO2 you can save, how much you're consuming, your solar design. So here it is. All right. So production analysis, how much percentage you want to offset. So I'm consuming this much, but solar energy is generating this much. So yeah. And here it is, the cash flow, the financial, all things you can enter here, and that's it. You can get an overview and get a description of your solar system. So that's it, guys. Make sure to like, comment, subscribe. Let me know what you think. I haven't really gone into detail, but just simple design for beginners to learn, and you can move up from there, play around with stuff, and yeah, that's it. Take care, stay safe. Let me know what else to make in the future videos. Take care, stay safe. Bye bye.